We are going to prove the following fact. The integral of cotangent raised to the nth power of x dx is nothing more than negative cotangent of x, but raised to the n minus first power over n minus 1, or minus the reduction. Cotangent raised to the n minus 2 of x dx. Proof. Unlike many of the reduction formulas, we are not going to do this by integration by parts. What we're going to do instead is break off two cotangent x's times the two that we just broke off. And what's going to happen when I rewrite that, I'm going to get the derivative with inner sign of cotangent of x. So this is equal to the integral of cotangent raised to the n minus 2 of x times cotangent squared x. But that is the cosecant squared of x minus 1 dx. So let's distribute this out. We have this times that to the integral of cotangent to the n minus 1 of x times the cosecant squared of x dx. And then we have this times that minus the integral of cotangent n minus 2 of x dx. Now this here, beautiful, looking perfect. The power of cotangent x has been reduced. So this formula and this formula, they look the same except the power got lower. Excellent. Now, let us do two things. One, just want to move that integral sign over a little bit, and let us look at just that. Let's formally write down the u substitution. If I let u equal the cotangent of x, what would du be? The answer is it would be negative cosecant squared of x dx. Okay, so let me sneak in a negative sign, not a minus. We're not subtracting now, but I have to put one out here. Okay, so there is my minus in front. What's in the purple box here is u to the n minus 2, and look at that, that's du. Well, I know that integral. Okay, minus, let's have our equal sign valid, minus this. So, whoops, integral, there's the minus. You add 1 to that power, and then you divide by that power, minus this integral. And now, we substitute back, and we say done. This is negative u over n minus 1 minus the integral of cotangent n minus 2 dx. I really don't want the brackets. In any case, it's u to the n minus 1. Don't guess. Look back. Oh, okay. I wrote it down. U is equal to cotangent x. So you want it to the n minus first power. So here is your reduction formula. And can't divide by 1. In fact, n has to be at least 2. Because, because if you only have n, if you only have 2, you really can't break off 2. Okay? Because if n was 2, then this would be 0, and that would be 2. But then on the left, we have cotangent to the second x, and on the right, cotangent to the 0 is 1, so you could ignore all of this, because 1 times this is just this. Oh, we're back to cotangent squared of x. Okay, so there's really no point for n to even equal 2, but it could be. It's more interesting when it's more than 2. That completes this proof. I hope you enjoyed it. Leave some comments in the comment section. If there's any videos or proofs that you'd like for me to make the video of, just let me know. If you have problems with my video, let me know. If you like them, leave a nice comment. Subscribe as well. See you guys in the next video. Watch and learn.